in order to identify a relationship as being an example of direct or inverse variation, remember we need to look for one of these two things. Either y is equal to k times x, or y is equal to k divided by x. And there's a possibility that neither of those is true, and in which case we don't have an example of either type. So if we have a case like this, where we have a table, we want to see if this is possibly an example of inverse or direct variation. We don't know which it is, so we pretend we just check with both cases. We'll try direct first. If this is an example of direct variation, then k should be equal to y divided by x. Going with that first example, it would mean that k is equal to 30 divided by 7. So if this is direct variation, then I would get that k is equal to 30 divided by 7. But if I check the very next one, I get 15 divided by 14. And the next one after that, I would get 10 divided by 21. You type those into the calculator, you're not going to get the same number. This is not an example of direct variation, so this doesn't work. The constant of variation, it's got to be a constant. It can't change. So it's not direct. So we try inverse then. We try inverse variation. If it's inverse variation, we would have k is equal to y times x. K equals y times x. So we would try k is equal to 30 times 7, which is 210. So 30 times 7 is 210. 14 times 15 is 210. 21 times 10 is obviously 210. So this is an example of inverse variation where k is equal to 210, and more generally we have the formula y equals 210 divided by x. And so that's what we could say as a consequence here. So that's our first example. We just look at k and look to see if k is in fact a constant for all of the different relationships, all of the different matchings that we see. So we look at the next one. Negative 5, 7, negative 4, 12, negative 3, 17. I'll try direct variation first. If the direct variation is correct, then I would have that k is equal to 7 divided by negative 5, and then 12 divided by negative 4, and then 17 divided by negative 3. And I already know that this isn't going to work. I mean, 12 divided by negative 4 should be equal to negative 3, but definitely 7 divided by negative 5 is not negative 3, and 17 divided by negative 3 is not negative 3. So it's not direct. Direct is out. So I try inverse. And so let's see inverse. It should be y is equal to k times x. So k is equal to y times x. K is equal to y times x. So I get negative 5 times 7 is negative 35. Negative 4 times 12 is negative 48. Negative 3 times 17 is, what is that? That's negative 51. So it's not inverse either. It's neither. This is an example of one of those cases where it's neither inverse nor direct, because doing 7 divided by negative 5 and 12 divided by negative 4 and 17 divided by negative 3, that wasn't constant. Doing negative 5 times 7, negative 4 times 12, negative 3 times 17, also not a constant. So this is neither. Let's look at a third example. We have negative 4, 8, 10, negative 20, and 12, negative 24. So we'll try direct again. We'll try that first. Doesn't really matter which one we try first, but you might think that this would probably be a good idea for us to try first. K is equal to y divided by x, apparently. K equals y divided by x. That's crappy y. Try that again. Y divided by x. So we have 8 divided by negative 4, which is negative 2. And then I have negative 20 divided by 10, which is negative 2. And I have negative 24 divided by 12, which is negative 2. I'm not even going to bother to check that. If it's to check inverse, I know that direct works. K is equal to negative 2. So I have k equals negative 2, And my formula then would be y equals negative 2x. It's direct variation with a constant of variation of negative 2. So we have that. The second type of example that you could look at, though, is where you're already told what type of variation it is. So, for example, the variable x varies directly with y, which means we're looking at direct variation here. When y is 7, x is 5. So we can then find k. We know that k is supposed to be equal to y divided by x because this is direct variation, which means then that we have that k is equal to 7 divided by 5. And so my formula is y equals 7/5 x, which is useful because now I want to know what y is when x is 15. I just plug it in. Y equals 7/5 times 15. Let's see, I'm going to do 15 over 1 and say that I can cancel those. That's a 1, that's a 3, and so I end up with y equaling 21. So y equals 21 is my final answer. Which should kind of make sense, because if x is going from 5 to 15, then it's being multiplied by 3, so y should be multiplied as well by 3 as well. 7 going to 21. That's a way that you can kind of check to see if this makes sense as an answer. One last example. The variable x varies inversely with y. Varies inversely with y. So now I'm looking at here, my inverse variation. When x is negative 12, when x is negative 12, that shouldn't be. When x is negative 12, y is 4. Let's say that that's what that is. I think that's what it says on your notes. When x is negative 12, y is 4. Sorry about the typo. Which means now I can make my, my constant of variation. K equals 4 times negative 12. So that's negative 48. I just multiply the two. I know it's an inverse variation, so I just multiply y and x. Okay. So I get that y then is equal to negative 48 divided by x. And now I want to find x when y is negative 6. So I'm just going to plug it in. When y is negative 6, I get negative 6 is equal to negative 48 divided by x. And I can cross multiply this. You can do negative 6 times x and negative 48 times 1. And I get negative 6x is equal to negative 48, which means x equals 8. X equals 8 is my final answer. So you should be able to take care of any question about direct or inverse variation. Again, if you're asked to identify which it is, just check whether or not the constant is a constant. Check one formula for the constant, and if that doesn't work, check the other. And if neither of them work, well then it's neither. And if you're told directly that it's either direct variation or inverse variation, you can find the constant of variation, use the formula, and then just plug stuff in.